Hello, this is Ariail. This is my Physics 2211 Lab 4 presentation. The purpose of this lab was to observe the motion of a mass on a spring and see how the energy principle applies. Physical principles used were Newton's second law, the update formulas, and the energy principle. The observed data was analyzed with tracker and inputted into a computational model in GlowScript to graph each energy over time. The total change in energy was 0 throughout the whole video, as a quick preview for the results. Newton's second law relates an object's change in momentum to the net force acting on the object. This equation was used because the object was undergoing gravity and a spring force. Finding the net force on the object, we could calculate the total change in velocity of the object, helping us iterate its position. Using the velocity update formula and position update formula, we could use the net force we previously calculated to iteratively calculate the new velocity and position of the object in each new time interval. The energy principle lets us relate the change in energies of a system to how the surroundings are influencing that system. In this experiment, there is no work being done on the system or heat being transferred into the system or out of it, so the change in energy is equal to 0 throughout the duration of the experiment. This equation was used to model the conservation of energy. For the system, the system was the mass, spring, attachment point, and Earth. The surroundings were nothing significant. The initial conditions were that the mass was 0.402 kilograms, the spring constant was 6.83 newtons per meter, the relaxed spring length was 0.123 meters, the initial position was 0.109 by negative 0.109 by negative 0.653 by 0 meters. Our time step was 1/210 seconds. In this experiment, a mass attached to a spring was dropped from rest. Using tracker, the x and y positions of the mass were recorded over time. This data was put into a GlowScript program to simulate the change in energies over time as the mass moves on the spring. For our initial conditions in the GlowScript, you can see the previously mentioned initial conditions inputted in the correct areas, as well as the formulas for the spring variables, as well as the energies. In the calculation loop, we started by defining our initial energies as the energy from the previous time step, and then we calculated net force and then calculated the velocity and position of the ball, and then we updated the spring, and then updated our change in energies. Following that, we graphed everything so we could compare to our tracker data and see how the changes in energy change over time. So as you can see, the change in energies oscillate back and forth as the strings move, but the change in total energy remains 0, demonstrating that the system conserves energy when there is no work or heat affecting the system. Possible sources of error are that when placing tracker data points, the point was not at the exact same place each time on the mass. The video could have been taken at an angle, which could skew the position data. There is air resistance that affects how the mass on the spring moves, and since this is not an ideal world, there is work and heat, even if it's minimal amounts, transferring in and out of the system. So what does it mean? Is the energy principle satisfied? Yes, since there's no work or heat acting on the system from the surroundings, the change in total energy is expected to be 0. When comparing this to the results from the GlowScript simulation with the tracker data, the findings match this expectation. So after calculating the average oscillation period for the x direction and the y direction, you can see that they're quite similar, but not exactly similar. This shows us that choosing different directions to calculate your oscillations will lead to slight differences in the periods. These deviations can cause differences in calculations, such as the spring constant. Thank you for watching. Have a great day.